What is event sourcing? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So I have another thought on architecture. So I had a 3-part series, and this is the 4th part. I didn't expect a 4th one. So there's an architecture called event sourcing. And I thought I'd try to explain what it is and how it relates to functional programming, because it's quite a nice functional approach to architecture. So we're trying to keep track of information about things in the world, facts, things that happen like events, which is data, right? Data means facts about events. And those events are things like the user clicked a button, or maybe it captures more intent, like the user wants to buy this, or the user changed their email address, the user changed their name, we received the shipment from the, we received an event telling us that the shipment was delivered, right? So these are all like events, and this information about events. So we want to capture that. Now, one thing that we could do, which is sort of the traditional approach, the approach that doesn't have a name, is to have a mutable flag or a mutable field in the database that it's either null or it has the delivery date. And so once we receive the shipment, or we know that the shipment has been delivered, we change the database, we change that field to say the date that it was delivered. Or if they change their first name, the user submits a form to change their first name, we just overwrite it in the database and we lose the old name, right? And that's fine, because in a lot of cases, you don't care about the history. I mean, it's just the way it is. You just care about what's the current name. But there's another approach called event sourcing. And what event sourcing does is it says, wait a second, why are we storing all this derived data? So we get this event that says the user wants to change their name, and then immediately we take action, which is change their name. And so what we're storing is the result of that action, right? And that could change again if they change their name again. We've lost that. We've forgotten that there were 2 events. We just know the last value. What event sourcing does is says, well, why don't we just store the events? Instead of taking action right away on the events, we'll just store the events. And then at any point in time, we can replay all the events up to that time and know what the current value would be. Okay, that this event log has a lot more information in it than whatever the current value of something is. And this is something that happens a lot. The thing that happens a lot is people say, well, people can change their name, so name has to be mutable, right? Or the shipment date will be set at some point, and it was either delivered or it's not. But that's true, but what it's missing is the notion of time. That I might want to know what was the user's first name at this time 3 weeks ago. Or I might want to know a really good example is someone's age. Like if you have an age, of course the age is changing. It should be mutable, right? Except we often want to ask, what was your age at the start of the year, right? That it's not about being, 21 today. It's about 21 when it was the day that you had the drink, right? Or like, are you 18 on the voter registration day, not 18 today, right? So there's all these questions of time that are ignored when you just say, well, ages change. Every day your age is a little different. Same with first name. People's first names change for reasons, right? Maybe the user is correcting a mistake. Oh, my first name was misspelled on my account and I'm changing it. Or maybe they had a legal name change. And so their actual name has changed in the legal sense. So then it's not really a correction. It was right before, but they have. So there's no place to put that semantics when you just say this thing is mutable. And in an event log system, an event sourcing system, you consider that event log to be primary. That is the source of truth. And you can calculate so many interesting things from it after the fact. Things that you hadn't even thought about wanting to calculate when you developed this, model of a user has a mutable first name, right? Like you could ask, how many times do users change their names? Or you can ask, how many times do they change their name? But then it doesn't change. Like they send an event to change their name, but it hasn't even changed, right? There's all sorts of little questions you could ask that weren't included in this model of the user can change their name, and now it's different. Now this brings up a bunch of challenges. Okay, before I get to the challenges, let me address why this is a good functional architecture. One reason is that it's data that doesn't change. If you have a mutable first name, it's not data anymore. It's just a string that you could change at any time. But if you have an event log, you record everything indelibly. Like you write it down, and now it's a record of that button getting pressed or the user intending to change their name or what have you. And it's stored with the time it happened, all the information around it, and that is immutable. Now, further, functional programming has a lot to say about this, because what you do to interpret this log is you run a reduction over it. You run a fold. You reduce this long stream, a linear sequential stream of events, into the current state of the system. Okay, so you start with an empty state, you have an event, you interpret it, it changes the state. Then you have another event, you interpret it, it changes the state. You have another event, you interpret it, it changes the state. Right? So at any point in time, you can take that stream starting from the first event and just replay it until you get to the time you want to look at, and there you go. You have the state at that time. Because it's a fold and reduction, whatever you want to call it. You can also call it a catamorphism. That's the more technical term. If you want to call it that. This is a functional idea, right? That you're taking this immutable stream and you're folding it and you're getting a value from that. All right. There's some optimizations, right? Because if your log gets really long, that's like a challenge, right? You don't want to replay that every time. So the way to address that challenge is you can cache the reduced value at different points. So let's say you want to say, well, we're going to remember the state every 100 messages, every 100 events. We're going to remember that. So at any point in time, the most events you have to replay is 100. That's not too bad, right? It's cheaper than saving it every time, and 100 events is probably not too long, too much calculation to do, to respond to a web request or something like that. Another challenge is you want to be able to search something by, or like look something up by ID, and all you have is this big event stream. You don't actually have like an entity that is indexed and stuff like that. So what people do is they derive an index from it. So they have a view that is not canonical, but that's listening to the event stream and building this index. So if you have an index that's like users and on their first name, so users indexed by first name, and someone issues an event that says, I want to change my first name, the index will be listening for that event, and when it sees that hey, I need to look at this kind of event. Some events have nothing to do with first name, it's okay, I'll just ignore them. But this one I have to look at. I am going to modify my index so that now the new first name will point to the record. Now, see, this is very interesting because it means that you have separated out your architecture from your use cases. If you have a use case that says we need a really fast index because we're going to be looking up people by their first names a lot, that is a use case that you can then develop. It's not saying that this is primary to our data model just because we have this use case. It's a very interesting property of this architectural pattern. Okay, so those are the main challenges, right? That a long event log will mean that you have it takes a long time to recalculate the current state, and you deal with that with caching, and you have the other challenge of having these like derived indexes on this log because it's not very convenient for doing fast operations on, like we're used to with stuff like a SQL database where you can just index any of the fields, right? But I like it because it has this other property of separating out the architecture from the use cases. All right, my name's Eric Normand. You can follow me on Twitter at Eric Normand. You can also email me any questions you have, eric@lispcast.com. Also find me on LinkedIn, just search for Eric Normand, and I'll see you later. Bye.